HR Analytics in Excel. Today we'll go through a full HR Analytics cycle. We'll start off with a question, we'll then look at the data, we clean the data, we analyze the data, and we interpret the data. Now this is the setting. Your HR manager comes up to you and says, I have a problem. The board of directors asked me to analyze why people are leaving and I can't get it to work. I want you to find out the following. First of all, why did people leave us in the last few years? In a normal dataset, we can see when people left, but we can't figure out why they left. That's in a different dataset, and we have so many people working for us, I can't figure it out. Second, are people still resigning at a higher rate than normal? Because a few years ago we had a lot of resignations, and I want to know how that's developing. And third, what's the trend in resignations? How do you think it will develop in the future? I'm not looking for very specific answers, I just want to see the trends. I have two datasets, one with normal demographic data in which each row in the data represents a yearly record, and I have an export of our exit interview system with information on why people left. But those two systems are not connected and I really want to know why people are leaving. Now it's up to you to find this out. This is the setting of the exercise. As you can see, the data is attached to this lesson. Download the data and scan through the files before continuing the lesson to get a sense of what's going on with the data. Maybe you want to give it a try yourself immediately. In that case, pause the lesson and have fun. For the others, I'll guide you through it. This is our step-by-step approach. So how do we get started? First of all, we'll transform the data to Excel worksheets by separating the values. Secondly, we'll examine the data. We'll clean the relevant data and we'll combine the different datasets. We'll then examine and clean the data again, and then we'll try to answer the questions by using pivot tables and visualizations. As I already said, if you feel courageous, you can use the dataset and try to do it for yourself. Now let's get started with the data analysis. We have two datasets. Number 1, the HRIS original, and number 2, terminated original. Now these datasets look like nothing you've seen before. These are extracts. They are CSV files or comma-separated value files. As you can see, there's multiple columns in the worksheet. You can see employee ID, term reason descriptions, which is termination reason descriptions, the termination type description, and the status year. But it's all in one cell. You can also see the output, employee number 1318, termination reason is not applicable, termination description is not applicable, and status year is 2006. What you need to do is to transform this information into an Excel worksheet, and I'll show you how to do this. If you click on A1, so on the top left cell, you can press Ctrl, Shift and the down button. It selects all the data until it finds the first empty cell. As you can see, all the data is now selected. What we want to do is we want to split this text into multiple columns. And to do this, you click on the Data tab, the data type, and you click Text to Column. And if you click, you can choose between delimited and fixed width. Fixed width is the option to go for if you have a fixed width for all the information. But in this case, we're working with a comma-separated value worksheet, so we can choose delimited. As you have probably already seen, the separation value in this document is a semicolon, not a comma. The separator may differ from file to file, but in this case the semicolon is nice because it prevents values that already contain a comma from being separated. On our screen we select that all the values are separated by a semicolon. As you can see in the preview, all the information now moves into separate columns. We click Finish, and here is all our information nicely structured. Now this lacks a bit of an overview. Let's make it easier to digest. We click a random field within the dataset with actual data in there. We go to Insert and we click Table to make this a table. We automatically get the range and we select the My Table Has Headers option because we have a row of headers. We click OK. And as you can see, the table is formatted. This is table number 1. The table represents all your employee IDs with their status year, so we know that employee 1318 worked in 2006, 7, 8 and 9 all the way up to 2015. And the termination reason is not applicable, which most likely means that this person is still working at the company. If we click the filters on the termination reason, we see that there's a number of options. Layoffs, not applicable, which means that people are still working in that specific year of record. Resignation or retirement. As you know, we can make selections in this data, but that's not something we want to do. Let's go to the other dataset and do the same. We open the dataset and we go through the same actions. All values are again separated by semicolons. We click on A1, Ctrl-Shift arrow down, and it selects all the records. As you can see, there are almost 50,000 records, which is quite a lot to be honest. We select the data, we click again Text to Columns, we click Delimited, and semicolon is already selected. We click Finish, and there is our data. To convert this into a table, we do the same thing. We click Insert, and we click Table. Yes, my table has headers. Okay, and there we go. We have a perfectly formatted table. You can see employee 1318, we see the birth date key, which looks incorrect, so we'll get back to that later. We see the original hire date key, which is also displayed wrongly. We see the termination date key, which is 1, but then sometimes it's also a really big number. We see age, and after we jump up by pressing Ctrl and arrow up key, we see length of service, city name, as you can see this is a Canadian dataset, the department name, the job title, so 1318 is the CEO, the store name in which the CEO works, number 35, probably the headquarter, the gender, status, whether the person is still working, and the business unit. Now the first thing that comes to mind is the weird formatting of this date. It shows as a number and not as a date. The way to fix this, and this is basically the first step of your data cleaning process, is by selecting the number format box, where you can specify the kind of data you're working with. Here I select short date. This transforms all the numeric information into dates. If I undo the previous action, you see that the number is 19,727. If I convert that to a date, the date is actually 1954. To apply this to all cells, also to the column next to it, which is also a date, I hold Shift, I click the arrow right button, I then hold Shift and Ctrl plus the down button. This selects all the relevant columns. And then once again I click Date, Show Date, and as you can see the original hire date of the CEO is now 1989. The dates from the source system were displayed as plain numbers. We then transformed it to the date that corresponds to the numeric value in Excel. This is a lesson that you can take home. When you export data, it's important to specify what kind of output field you have in your Excel file. Why? Because if a date is messed up, it's usually quite hard to fix. In this case it looks quite nice and it's an easy fix. If we jump down, we see that it looks nicely structured as well, so there's probably not that much noise in the data. If we go through the document, I don't see any weird values, and it's the same for birthday. For example, I don't see any weird 1900s values, for example, which you would expect in the case of missing or default values of 1, as most systems see 1900 as the first value on a calendar. So that's good. And then we have the termination date key. For the top rows it has a value of 1. If I scroll down, I do see some actual values. For example, here I see a termination date for someone. Let's click Show Date again, and then we see the actual termination date. This can be a past date in case someone left the company, but in some systems it can also be a future date in case of a planned retirement. If we transform all the values, we see that all the values of 1, as I previously said, jump to 1900. These are the default values and these people are probably still active. That's something we need to keep in the back of our mind. We could delete the data, however. I'll undo this action so it goes back to the default values. This is safe to do as we don't need the termination date. I'll show you later why we don't need it. Remember, the question we were asked was, why did people leave in the past few years? To answer this question, we need to identify who left. And the easiest way to do it, if you scroll through the dataset, is to look at the status of employees. Here the status is either active or terminated. So we just select the employees who were terminated to determine who's not working for the company anymore. Remember to sort the rows by employee ID to make sure that there are no double matches. Now, for example, if you look at the director of training, we can see that he has been terminated. But we don't know when he's been terminated, nor what the last input, the record date, was. This is because the values are, again, numbers and we can't interpret them. We should therefore convert them into dates once more. Let's do that. We select all the data of the column record date to make sure that we have all the relevant data. As you can see in this column, some values are just plain numbers while others are actual dates. This means that there is an area in our data that we need to clean up. Select Show Date. The system recognizes which year someone has a record in. When we scroll up, we see that in the case of employee number 1318, which is the CEO, we have a record of him in 2006, 2007, 2008, all the way up to 2015. So we have yearly records for every single employee until they're terminated. Because if we switch to the people who are terminated, we see that there are only unique employee values. No one is terminated twice. So this means that once someone is terminated, they are removed from the system. In other words, the next year you won't see them in the system anymore. How do I know this for sure? Well, there's a simple way to check this. I select all the data of the people who are terminated and copy-paste it in a new document. As you can see, we have 1500 records of people who are terminated. If I select all the data and ask Excel to highlight the duplicate values, nothing happens. It appears that there are no duplicate values. I can double check this by manually entering a duplicate value. Immediately Excel notices it and highlights my duplicate in red. Now I can close the document and save it just in case. What I learned is that once someone's status turns to terminated, they are out of the system. The following year they won't be in the system anymore, and this is interesting to know because it means that termination will not reappear every year for the same person. So there's only one single record for every employee who left the company. This means, and this is important, that we can filter on termination. So to answer our first research question, why did people leave? We now know that we can use the termination status as a key input. The way to answer this question is to insert a pivot table. And yes, we select the entire table. In this pivot table, we want to know someone's status. And then we want the year as a selection so we know in what year people are terminated. But now, as you see, we run into a problem because we need to segment on year. However, as you can see in the pivot table, there's no label that's titled year. The only thing that we know is the record date key, which is the date on which the record was changed or created in the system. As you can see, this is a date function, but it doesn't give a good overview of the year that someone is terminated because the structure is unusual. Every system that you will work with has a unique data structure. To create an overview of the year, we'll create a new column and call it status year. This enables us to ask who was terminated in what year. To do this, we use the following formula. We want to use the record date key in the cell, and in this case we type equals and year. As you can see, the explainer says that it returns a year of the date between 1900 and 9999. So that's quite some years in the future. After typing year, we open a bracket and we say, I want the year from cell record date. We close the bracket and we press enter. But now we get an error. That's interesting, we need to fix it. When I open the function argument by clicking on the fx on the top left corner of the screen, it says that there's an error in the value. This means that this specific date was not recognized as a date. It's only seen as a complicated number, not as a date. So in this case it's set up in the wrong way, in a faulty way. The data input was therefore not successful. This is a problem that you'll run into very often when you work with data and especially when you work with dates. Excel is quite horrible at processing dates, and this also has to do with the difference between US and European notations of dates, where in the US the month comes first and in most of Europe the day comes first. This is all part of the data cleaning process. Let's see how we can fix this problem, clean the data and get everything in check so we can make the selection for the specific year. There's probably something wrong with how the date is recorded. If we scroll down to the traditional date, Excel does recognize the values as dates and turns them into specific years. But in the top part it doesn't, so the original imported file probably changed at some point. And we're back at the original file. Let's take a look at what went wrong with the date. As you can see here, while I'm scrolling down, every cell has a similar structure. First it contains a long date and a time, then a short date or a number type of date. The change in format is probably confusing the system somehow. Now I'm just scrolling down really quickly. At some point I see in the output data that there's a second type of value that's just a number and not an actual date. It probably means that we have a fault in our original file or that Excel interpreted the data differently. That's not really a problem because we can fix it. And that's what this exercise in the end is all about. How are we going to fix this? We select data, we select text to column and we go through the same steps. We take the record date and we scroll down all the way until we get the nice even number. So we know we can convert the numbers to a date, but the values before that, those ones we can't convert. Once again I select all the data, I click Data, Text to Columns, I select that I want to use the space as a separator and I press Finish. As you can see, now I have an original column with only dates. This is the format that Excel should recognize. So if I say, hey, this is a short date, I click it and Excel does recognize it as dates. If you select it again but then define it as a general number, Excel doesn't recognize it anymore, so that's bad. The question is, how will we change this? Before getting into this, let me remind you that in Europe, dates are notated in the following way. You first have the day, then the month, and then the year. As I already said, this is different from countries like the US and the UK. Back to our problem, how do I fix this? I select all the data, I click Text to Column, and I select a delimited value with a slash. This will split my dates into 3 different columns: month, day, and year. Here the day has been interpreted by Excel as time, but now I'll turn it back into a number. Now we will copy the second column and paste it to the left of the first column. This way we have the dates in a European way: date, month and year. So what I then do is I insert a function and I pick the concatenate one. What this function does is that it joins several text strings into one single text string. So first I select A1 corresponding to the day. Then I enter a dash. Then I select B1, so the month, and then a dash. And then finally I select C1 corresponding to the year. After clicking OK, it should say 31st-12-2016. Now we should turn it into a table because that will make things much easier. All I have to do is insert a table without headers. I create a new date column, and what I basically do is I use the same formula as previously, and as you saw in the previous lesson, the biggest advantage of having a table is that it auto-completes. And here's my data. The only challenge with this data is that it's a formula. It's not a fixed data point yet. To change that, I simply select all the data and I copy and paste it using the paste options, the just paste the values. When I do this, the formulas have been replaced by concrete and static values. Now I can easily obtain a year by typing in a cell equals year, and then click the corresponding date in the date column. It works. So now we've created a date. I haven't changed the order of the rows in any way, so that's good. I should be able to go back to the previous file and just paste the values in there. This should give me a solid date. Then I select the remaining data and ask Excel to give a short date for these two. It all works out, and I can now create a year function that will actually work. So let's do that. We create a table. We want to know the year function, so we call the column status year. We enter the formula equals year for the column record date, and we press enter. We now get a status year for everyone. So every time there's a new input, we get a new status year. That's good. Now we can try to insert a pivot table like we tried to do before when we ran into the time and the year problem. And welcome to the world of data cleaning. This is what data cleaning is all about. We have a pivot table. We can sort using status year, whether or not someone is terminated. And then as the actual value, we can get the count of employee IDs. We learned how to work with count before, and now for every year you see how many people are active and how many people are terminated. Based on this data, we can create a chart. I pick a 2D column chart and include all the data from the table. The chart shows us that there are people being hired, so the population is growing. Regarding the people being terminated, there was a peak in the previous year, in this case 2014. This means that more people left the company in this specific year. However, the number decreased again in 2015. This is a quick and dirty overview and a first answer to our question. To do it better, we need to go back to the pivot table. I want to show you the importance of structuring your data. If we move status year from the columns to the rows and status from the rows to the columns, we see that the table is much easier to read. What we can do now is create a bar chart for the year and status. As you can see, we now see the distribution of active versus terminated employees. If we then change our columns in the pivot table to just the people who are terminated, and we then make a bar chart, we actually see how many people are terminated. So we see that in 2006 about 130 employees were terminated. In the following year this number goes down and then up and then down again. So this is a very simple and quick way of showing how many people were terminated.